Good morning, one and all. I'm Shuganya IS, working as an assistant professor in the Department of CSE. And now we are going to see some basic introduction about the digital logic and computer organization. And our first unit is digital fundamentals. These are all the syllabus that we are going to see in upcoming video. And our first topic is number systems. What does this number system means? The process of converting or counting the various items into a number. How we are counting these items into a number system. That's what we are going to see further. Basically, we are having 4 types of number systems. First one is decimal, which contains the value from 0 to 9. That is, total number of values will be of 10. That's why the base value of decimal has been specified as 10 here. And binary means which contains the values 0 and 1 and the base value is 2. Octal means the value from 0 to 7 which has a total value of 8. That's why the base value of octal is 8. And hexadecimal, 16 numbers in which we are having the values from 0 to 9, and the 10th value will be taken as an A, and 11 will be considered as an B, 12 will be considered as an C, 13 will be considered as an D, 14 will be considered as an E, and 15 will be considered as an F. Totally 0 to 9 numbers, and for 10 to 15 it will be replaced with an uppercase alphabets A to F. So totally we are having 16 values which has a base value of hexadecimal 16. And here we are having some basic conversions. This is the decimal value 0. Hexadecimal will also be considered as a 0, and binary is 0. And this binary has been represented in an first 3 form, that is 1, 2 and 4, that is octal form. And second is 1, 2, 4, 8 in 4-digit form. So the value 0 can be represented in a 3-digit form as well as in 4-digit form, also in binaries. And here are the conversions. Here the decimal number 1 and hexadecimal number 1. So in the place of 1, we have to replace with 1, and all other places will be occupied with 0. Here I have specified as 2, and here hexadecimal as 2. So in the place of 2, that is in the second position, we have specified the value with 1 and other places with 0. And in the value 3, we doesn't have a direct value 3 here, so we are adding 2 values. 2 plus 1 is equal to 3 here. So I'm putting 1 in the place of 1 as well as 2. So you can see here that in the place of 1 and 2 I have specified as 1 and 1, and in the remaining places it was mentioned as 0 here. And in 4 directly I am having the value 4 here. So I can put 1 in that place and the remaining places with 0 here. And fifth, I didn't have a number 5 directly here. So 4 plus 1 will be taken as an 5. So in this place, I have to put as 1 and 1. And the remaining places will be filled with the 0. That's what we have done for the entire 0 to 15 values. And in the next slide, what does this represent means? Now what we are going to see is, basically we have seen 4 numbers, 4 number conversions. number systems. So how we are going to convert this number, if it is of hexadecimal, how it has to be converted to octal, hexadecimal as well as binary. If it is of binary, how it can be converted to decimal, octal and hexadecimal. That's what we are going to see in the next slide. Our first conversion is binary to octal. Our first conversion is binary to octal. As I said earlier, binary means it has a base value of 2. It contains two numbers, that is 0 and 1. The combination of zeros and 1 is called a binary number. If the number is having the value from 0 to 7, that is called as octal number. So here we are going to convert the given binary number into an octal number. How come this conversions can be done means, here we have taken this question. Okay, this question, this binary number is going to be converted into an octal number. If octal means totally we are having 8 values, it ranges 0 to 7, that is 1, 2 and 4 form. If you are adding all these 3 values, you will get 4 plus 2 is 6, 6 plus 1 is 7. So if you want to convert the binary number into an octal number, the given binary number has to be converted into a 3-digit form. Why we are converting that into a 3-digit form means it is an octal number which has a range of 0 to 7, totally of 8 values. That's why we are taking 3-digit form. Right. And now here the question has been taken here. This is our question. This question, how come we can convert this binary number into octal means, this is the question. So we have to follow the direction from left to right. Right? So the first number is 1, 0, 1. That has been highlighted with yellow color, our first digit. And second number is 0, 1, 0. From this itself, you can understand that I am following the direction from this side. Right? I am following the direction from this left side to right side. And my third number is 1, 0, 1. What I have to do next is, my first number is 1, 2 and 4. So I'm specifying as 1, 2 and 4. Wherever I'm getting the value 1, those two values has to be added and that will be written as an output. Here 1, 2, 4. So in the place of 1 I'm having 1 and in the place of 4 I'm having 1. So totally I'm having the number as 5. Here 1, 2, 4. In the place of 2 I'm having 1. So it has been specified as 2 here. And 1, 0, 0. 1, 2, 4. In the place of 1 I am having 1. So it has been mentioned as 1 here. So 1, 2, 5. This binary number has been converted into an octal number which is of 125 with the base value of 8. This is the way in which we can convert the given binary number into an octal number. Now we are going to see that how the fractional binary numbers has to be converted. In this, if it is of simple number without a decimal point, it has to be followed from left to right. And if it is of with the decimal point, the same. Before the decimal point, the as of left to right direction has to be followed, and after decimal point, right to left has to be followed. As we said, we have split the numbers from this direction, and for after the decimal point we have to divide the numbers in this direction. So I'm splitting the numbers into 3, 3, 3, and if 0 or 0 is not available in any one of the corner means we can add the 0 by ourselves for our understanding. Right? In this direction, the first 3 digits has been taken, so it has been specified,
and next 3 digits has also been taken. Even though the numbers directions has been changed, we should not change the order of this number. This number orders should not get changed. Here I have specified as 1, 2, 4. So I am giving 1, 2, 4. 1, 2, 4. 1, 2, 4. And here also what I have to do is 1, 2, 4. 1, 2, 4. For example, if we are having only 1 and if we didn't have 2, 0 means that too has to be taken under consideration, and it has to be numbered only in the form of 1, 2 and 4. Directly we can't give this value as 1 here. Then our answer will be wrong. So for assumption we have to consider the two zeros, and for those values only we have to calculate as 1, 2, 4. Here we have taken as 4 and 3, and this is the way in which we can convert the given binary number into octal number. That's all of today's class. We'll see the remaining in the next class. Thank you.